Huh? Should be there. Okay. Fit. Do you see it? Still don't see it? You see it, Mr. Gaddy?
I don't see it.
Huh?
Oh yeah, I see them.
Okay,
It
okay.
popped up.
All right, buddy. Okay, so let's look at chapter 4. All right, minimize this. We'll go here. All right, chapter 4, we dealing with the decision. We started that, huh? I have my other class. See, my two classes kind of run what and what, but it's a little different. But I'll kind of teach them similar. Here we go. In this chapter, we're going to deal with the decision structure. What we've been dealing with previously is what? Well, outside of functions, is what? Everything is what? Statement by statement by statement by statement by statement, we finish, right? Now we may be branching off and executing something and then continuing, or branching off and executing something else and continue, all right? So, with the decision, it's like if I ask Mr. Gaddis, I say, Mr. Gaddis, go to the Coke machine, and if there's a Coke, buy me a Coke. What you should come back with? If no, there's no Coke. Nothing, right? It should just come back. But and so that's one condition, all right? That's one type of if. If X is greater than 5, give them a bonus. Otherwise, just continue. So if X is not greater than 5,
If there's no Coke, then give me.
No, but that's different. That's a if else. Right? So, but right now we just dealing with the if.
Okay.
Right. So, but because they're both valid conditions, you can have just the if, or you can have the if else. Give an example with an else, and then I'll give it to you with numbers. I can say, Mr. Gaddis, go to the Coke machine and buy me a Coke. If there's no Coke, buy me a Sprite. So if you go to the Coke machine, what you looking for first?
Coke.
Okay, and if there's a Coke?
That's Sprite.
No, if there's a Coke,
then bring it back.
you're going to bring back a Coke. But if there's no Coke, then you'll look for a Sprite. And so you understand? So that's the if else. All right? And now, it's kind of like if I had, if I give a test and I say, okay, everybody who made above 75, I'll give them 10 bonus points. And everybody less than that or less, I'll give them 2 bonus points. So that would be what? If else, right? But if I said everybody who made greater than this, I'll give them 10, and the rest nothing, it'd just be a if, right? So that part would be like if grade is greater than 75,
right?
Add 10 to score,
right?
Else add 2 to score. You got what I'm saying? So if it's true, it's gonna add 10 to whoever scored and skip the add. 10 to everybody that score and skip the add 2. But if it's 75 or less, it's gonna add 2 and then continue. Right. So that's the difference. That's now we also have nested ifs. Okay. A nested if would be an if on top of an if on top of an if on top of an if. Example, if I ask you, if grade is greater than 90, do something. Else, if grade is greater than 80, do something. Else, if grade is greater than 70, do something. So I got all of those ifs nested within each other. Okay? So I can do that. What else? With the ifs. But then there's if, but then to kind of get away from spaghetti code, you can use case statements, right? And we'll go over that too. What a case statement does, it allows you just to present the value that you're comparing for whatever reason, and then if it's that, do this, do this, do this. If it's this, do that. If it's this, do that. If it's this, do that. And you're not asking if, you're just blocking your data, okay? And saying do this, all right? So we'll go over all those. So let's look at our if or our decision structure, all right? It says a decision structure allows a program to perform actions only under certain circumstances or certain conditions, all right? A control structure is a logical design that controls the order in which a set of statements execute. And look, so far we've been writing code that what? Line by line by line by line by line by line, we finish, right? Now, which is this, display this, declare this, display, input, display, display. That's pretty much what we've been doing, right? But look at this. This is an example, say, and this is more or less of a life example. If it's cold outside, if that's true, we're gonna do what? We'll wear a coat and continue, whatever else activities we got to do. But then what? If it's not cold outside, we just gonna continue with our what? Regular activity. So see, that's how an if statement works. Now, looking at this flow, this is part of a flow chart. That decision symbol, that diamond, that's where you ask the question. If it's cold outside, then you got how many different possibilities?
Two.
Only two. Yes or no. True or false. On or off.
So when it's nested, will there be multiple?
Right, but it's all gonna be grouped. Remember how we talked about how would I say your scope?
Yeah.
Right. Because you'd have your curly braces to depict.
So those nested, they're still gonna be true or false too, right?
Right, correct. Because when you ask the question, you will have a true or false given. And I'll show you in a little while how it evaluates that, to true and false. Because really, when it compares an expression in an if statement, the program really returns a 1 or 0. Okay? And run on 1 for true, 0 for false. All right? All right, so it tells us this diamond allows us to determine whether or not it's cold outside. If it's true, we're performing this, and then we're gonna just come back in the logic and continue on. If not, we're gonna skip this, and it allows us to just continue on with the coding, all right, the code, all right? But look at this, all right? So, if you look at it, if we take this out, this would be like just a normal, regular warm day, right? Step by step by step by step by step. But then now what? Oh, if it's cold outside, we're gonna add something, all right? Add activity and then continue. But if it's not cold, we just continue, all right? So, and now, look at where it's true. We only have what? Wear a coat. That's like one instruction. But we could have what? Many instructions, just like in C++. We can have many statements that we want to perform if it is true, right? You're not limited, right? So you can have many instructions.
Practically though, in real life, how do you take into account every single little thing?
In what, in real life?
Yeah.
Okay, how would I say it? Do you have to? And when I give, let's use, you have to, and I'm gonna use traffic lights. If you if you program your traffic light and you miss one circumstance that could happen, what would happen if you put it in the plate? Well, if you put it live? What could happen?
I mean, it could cause a wreck.
Cause a major accident because people gonna what? And I had to tell my kids about when my daughter when she first started driving. The light, just because it's green, does not mean to go.
Right.
That give you access to go, but just make sure what a car's not flying by and passing the light. So the thing is, if you program a traffic section, traffic light, and you miss one scenario, it can cause, or what it can cause is a stalemate.
Right.
Where you have one side of traffic just waiting or whatever. So that's, you always have to program for every scenario. All right. Now you ask, how do you do that? That's where your team come into play. You understand?
Yeah, because maybe you're just one person who did that. I mean, it'll take.
It can, yeah, you can make mistakes and you can forget stuff. That's why testing is a big part of coding, right? That would make it a science too, the testing part. Because you design, just because you design something don't mean and it works and you think, oh, it worked perfect, doesn't mean you go and implement it. You understand? And in our system analysis and design and the other computer classes, it tells you you never want to push like a new version or a new product to your entire company.
Right.
You may push it in just a small division or department to do like a trial run, a test. And pretty much if it works with that, then you can push it out to everybody. But if you push it all out and then everybody start having problems, then now you might be down for a couple of days because now you got to kind of try to revert back to the old way, and try to work on what you have to work on. Right. So that's one of the things you have to watch too. Now this is just some computer knowledge that you need to know.
Right.
So when you are creating a program, testing is a big part of it. Understanding the problem, go back to that, is a big part of it. Then if you're in the real world, you're working with, like say we're doing the traffic light. We're working with maybe DOTD, working with the city, working with the federal government, because it might be a certain amount of time, a time limit on turn signal. Might be a time limit on yellow to green, green to red, So all those different things, you have to try to be in accordance to the law and whatever.
In coordination with the crosswalks. And
correct, all that stuff. And then once you get all that, then you're going to flow chart a schematic as to how everything should work. And like I say, you run through it. If it's a crossing lane, okay, and you got three lanes coming this way, where two go across, then one turn here and one turn, you got to take consideration. You know what I'm saying? So you got to prepare for all of them. So it takes time. It takes time. And what you might do is just do a subset where you just start on one street and then see what's going on with the other. If this happening on this street, what this one do? And then if this happening with this one and that one, what do they do? And then you start putting it all together to see if it actually can jive together, right? And then too, what they do, they even do research as to how much traffic is flowing, so that I can know how long to leave the light red or green so that traffic won't be oversteering. So there's a lot of research. And you as a programmer, you'd have to be in a lot of those meetings because you're going to be the one.
Half the time you're not even coding. Half the time you're just talking.
Correct. You understanding the situation. Right. Correct. And that's why I tell you, whether it's chemistry, physics, math, or the real world you say, man, I don't deal with making roads. May not. But you coding, for that light, or you coding for the crosswalk, you coding for whatever. You understand? Right. And that's how it works. But you have to code for everything. Got to. Because you can run into issues. Or now, what some people may do, they might create something that's small or light and upgrade at times. Keep upgrading. Make it to where it can work, on a small scale. but then keep upgrading it so that it'll eventually be a full functional whatever. All right? So, and like I said, if we look at this one, you only have one thing that you're doing if it's true, all right? But then look here. If it's cold outside, wear a coat, wear a hat, wear gloves. So you can have multiple statements as to what it is going to be doing, what you're going to be doing in that, for that true condition, all right? So, give an example. Let's do this. Let's go to online GDB and I'll show you how a if statement looks, all right? Because here in this chapter or these books, the book we're using is just showing pseudocode. So let's look here. All right. Choose the language. And, all right. All right, so this is our shell. All right, so here I could say int, and I could give a value. I'll say num is equal to 10. All right. So now I can have an if statement. Normally, an if statement is your if command, and then whatever your criteria is, or your test in the parentheses. So I would say num, and now. Well, I didn't go over them yet, but what are some of the relational operators, all right? What allows me to compare numbers? Or what it is I use to compare? I compare numbers to check whether they're what? When I compare two numbers, I can compare them to see if they are equal, greater than, less than or equal to, greater than or equal to. One more. Not equal to. All right? Right? Okay, so those are all the operators, all right? Now, those operators, what I'll do, I'm going to just type them out right here, all right? So you can see them, all right? It's not in the program. All right, greater than, that's the greater than symbol, right? Less than symbol. So see now how your math skills coming into play. Because if you write in code and you say, oh, I want to test to see if X is greater than Y, but you writing in your code X less than Y, your logic will not work right. And you looking at it scratching your head, why it's not working, why it's not working? I wrote it in there, why it's not working? Because so you have to tighten up on your math skills. You have to know those signs, all right? Now, greater than or equal to. That's the symbol. Everybody see that? Now, if I say X is equal to 6, right? Y is equal to 5. And if I say if X greater than Y, I'm gonna just put X, I'm gonna do X equals 6, Y equals 5. If I say X greater than X greater than Y, is that true or false?
It's true.
True. If I say X less than Y, false. If I say X greater than or equal to Y,
That's true.
that's true. Greater than or equal, one or the other, not both. You got it? Then we got less than or equal to. So if X less than or equal to Y, true or false? False. Now, look at this one. Equal. Two equals, not one. One equal does what? Assigns the value. Two equals, compare those two values. You gotta remember that. As a beginning programmer, you're gonna run into those issues. And I'm gonna show you the hang up with that in a little while. All right? Then there's the other one called not equal. So, Mr. Bennett, why you didn't use the word not? Because we have symbols to represent that, class. The exclamation point equal is not equal. Now, so So I'll just leave that here and I'll comment them out. All right, so that's there. So here, I have int x num equal 10 if num greater than, I'll say what, give me a number. 22? All right, so if it's greater than 22, I'll just say, okay. I'm gonna just put anything. I'll just say true, all right? Okay, I'll put true. All right, so if I run this program, what's gonna output? Nothing, correct. Because, and now this is one thing that I do, and if you notice, I have curly braces around the cout. But my program will work fine without them. The reason being, if you have only one statement that's tied to that if statement, you don't need curly braces. By default, it's gonna perform that one statement. The problem comes if I had multiple, like remember we had wear a hat, wear a glove, and whatever. When I want multiple things to be done, if it's true, then I need to group it. If I don't, it's just gonna do the first one and it's gonna automatically do the other, whether it's true or false, right? If it's false, it's gonna skip the first one by default and do the rest. Give you an example, watch this. If I do the cout true, then I'll do cout, and I'll just say, BRCC and cout. I don't want to do this one. Okay, now, I'm gonna ask you this question. It's gonna ask if num is greater than 22. Is num greater than 22?
No.
No, so what's gonna output? You got it? By default, the first one is attached to the if statement because I didn't put the curly braces. And sometimes students get caught up with that. But that can throw your logic way off. You understand? So I recommend, being that you're a beginning programmer, anytime you have an if, block it off. Block the whether it's 1, whether it's 5, or whatever. That's why given that, if you ever have to go back and add statements for that true part of that if, you know where your body begins and ends, and you're not trying to say, oh man, I forgot my curly braces. I don't know where to start and stop, and I gotta go back and start all over. So we know that here, if num is greater than, well, let's run it though. Let's run it to prove our theory. If I run it now, all right, it's gonna give me what? BRCC and program ended. Because what happened? It says, okay, if num greater than 22. No, it's not. This one is associated with the if. The other two is just continued on with the program. Everybody got that?
Even if it's in a curly bracket?
No, now if it's in a curly bracket, that's different.
Yeah.
That's what I'm saying.
Oh.
But I'm just trying to show you might see code that looks something like this. And you're like, well, Mr. Vester, they got that. How does it not do the other 3 lines? Because it's not associated with it. By default, just that one line.
Right, because neither curly brackets.
Now, if I use the curly brackets, I can tell it where to begin and where to end. I'll say, okay, start this if, the truth for the if here, and I can say end it here, or end it here, or end it wherever. So now I could do this, okay? So now what happened? If the number is greater than 22, I'm gonna print out true and BRCC, and then it's still gonna print out what? Program and ended. Now, if it's not, it's just gonna print out
Program.
So you understand the difference in that logic. Everybody see that? The difference in that logic by just using the curly braces. Right? And
So if it was true and there's no curly bracket, right?
okay.
And that true.
Everything will print out.
Right.
Everything. It'll print out true and the other two statements.
So the best thing you could do is just remember to put the curly bracket.
Right. And the reason why I say that, because what if I have to go back, say I wrote a program and I say, okay, if this is this, or I just want to print out whatever. But you got like maybe 25 lines of code, 50 lines of code. But then you go back, oh, if that's greater than that, oh, but I want to print this, but I want to add this, this, and this. And you forget to put the curly brackets.
I can see how that's easy.
You understand? So the best thing to do, always put them. So when you go back to modify, you know where that true, know where that false, or whatever condition is. But you don't have to. But you're going to have to remember when you start modifying. All right? All right. So, like I say, if we did this and we made it true, right? Now it's gonna print what? All three of them, right? So run it. So it's gonna print the one that's tied to it, which is true, and then it's gonna also print programs and whatever. You got it?
So how is the computer nodes attached to that first line?
But it's defaulted. By default.
Okay, so
just by
that's
default.
the file we're doing.
Right.
Okay.
That's by default. Correct. Now, and like I said, I'm not in the notes, but I'm gonna go back to the notes. There's another thing that you should, two other things that you should not do. One of them is this. Class, if I do this, what happens to my program? Well, first of all, what I'm gonna do, I'm gonna change this back to this. All right. If I change this to this, what should print out?
Just BRCC and program ended.
All right. When I do this, what should print out? Oh, should I get an error or what?
Nothing's gonna print out.
Huh?
Nothing's gonna print out.
It's the guy that says nothing.
You need Mike in there because it's gonna end the program right there.
Huh?
Gonna return it.
Okay.
Solve it.
You're gonna print out 22?
No. It's not CI
Would it
22.
just print out the CL?
Huh?
Would it just print out the CL? No, it would have to be an error.
It's no error. What would happen? Well, when you put the semicolon, you're ending your if.
Right, so what's that?
You ending it though. You saying that, hey, I'm finished with my if. Continue on with the program. So what's gonna print out?
Nothing. It's gonna
What's gonna print out?
those three lines right
Those three outputs. Cause my if is only that one line.
there. So it's only gonna see the CL.
It's right.
Right.
Right. See what happens is when I put a semicolon at the end of an if, I'm nullifying the if. Yes, ma'am.
So if you ran it, it wouldn't make sense, right? Because
Right, because the if is not a part of the logic no more anymore. So when I run it, watch what happens. You understand?
Yeah, I get what you're saying, but it's not the same.
Right. It's not the same because if you write this program and you ask it if num is greater than 22, what you want to do?
Oh, yeah.
What do you want to do?
Right.
It's nothing you're doing. So it's like you don't have if logic. You just executing everything statement by statement by statement.
Right. Just like input, output, input.
Right, without a condition. That's a no-no. Do not put a semicolon at the end of that statement. All right? Another thing you do not want to do. Remember I told you about the equal sign, right? Now, if I want to check to see if num, which is equal to 10, right, is equal to 22. If I do this, what am I doing?
You're changing the value of num.
What I'm changing it to?
22.
So I'm making that statement false. I'm making
Oh,
that
you're making it true.
always true.
Yeah.
No matter how many times I execute it,
It's always
I'm assigning them to be 22 and it's true.
Right.
You got what I'm saying? No matter what I put up here at the top, when I can set it up to 1,000,000.
Right.
It's gonna be set back to 22. and it's gonna make it true. It's gonna perform the first statement, then the rest.
It's almost like asking the user to input 2,000, whatever, it's always gonna be 22.
Right, it's gonna be defaulted to 22. Correct. So if I run this, it's gonna say 20. It's gonna say true and continue. So let's run it. It's gonna give me all three statements. See, right now. But when I do this, put the double equal. Now I'm doing what? I'm comparing the value in num to 22. So is 10 equal to 22?
No.
No. So what's going to output?
BRTC and program ended.
Correct. Because by default, this one goes to this, right?
Right.
It's tied into that.
But the color practice around all three, and then it wouldn't output anything.
Right, correct. Right? So run it, and look, you only get what? BRCC and program ended. So you see those little do's and don'ts or whatever, you gotta make sure you understand it, because it can give you headaches. When you start dealing with if logic, man, it can run.
That's what you're saying. You're talking about the nets. That sounds pretty.
Yeah, that's difficult too, because it's like you got to kind of know. And the thing is, you want to create your curly brackets and keep them on levels so you understand where and what goes with what. All right. So, and the nested, the book gives it, and I even give it. Normally, they use an example of a grade, a test score. All right. If I told you to write a program that will input a test score. Given that test score, I want you to output the letter grade, where if they make from 90 to 100, it's an A, 80 to 89, it's a B, 70 to 79 is a C, 60 to 69 is a D, and anything else is an F.
So you have to nest that.
Correct. Well, you have to nest it, because if you don't, then you're writing your code your code to where it's executing unnecessary code, which takes up time.
But if you put if 90 is less or whatever, 90 less than 100 or whatever, C out A, right? Couldn't you just put if else?
Else if.
Or else if?
Right. Because what? If the first one is true, it won't do none of the other else.
Right.
So you done skipped all those the execution of all those statements. You got what I'm saying?
Yeah.
But if you try to put them each one, if X is greater than whatever, do this. If X is greater than whatever, so now it's going to execute each one of those statements, which costs time,
Right.
of execution in your program. Right?
Yep.
All right. So let's look at that. I'll reduce this a little bit, and like I said, you're kind of moving forward a little bit. Say this is score. We could type it in or whatever. Let's say score. All right. Say score is equal to 82. All right. So here we want to say if score is greater than, what's the first range? What I say, 90, right?
Yeah, 90.
Now 90 to what?
100.
100. Now the thing is though, let me ask you this question. I'll put this on. Well, let me do the next one. If it's greater than 90, what I want to output?
A.
I could just say letter grade. I'll say grade. I'll do grade.
Wouldn't it be greater than equal to?
Right, because what? If I don't, then a 90 would be maybe a B, depending on my logic.
Yeah.
You're right. I'll say char grade. All right. So here, greater than or equal to 90, right? If that's the case, what we're going to say grade equals B, right? Not B, A. All right, but now, like I told you, I like to put the curly braces just to make sure I understand those whatever, right? But now look at this. I've only checked for what? I've only checked for what grade? A. So now I need to check for B. So now what? If score is greater than or equal to 80, all right?
using the single quotations because it's char, right?
Correct. Grade equals B. Now, class, let me ask you this question. The first one I asked if it's greater than or equal to 90, right? So what is going to check for all the values 90 and above? But then the next one asking if it's greater than 80. What if it's 90?
It'll still be empty.
Huh?
It'll still be included. Right?
Oh, no, I forgot this. Huh?
Else if.
So what happens? Listen, a if statement can have what? True or true and false, right? So if this is true, it's gonna do this and what?
Oh.
Keep going out.
So you don't
Else
have
is
to do it.
basically.
Right, will not do it because it's the else.
Right, so else is basically saying if not.
Right.
So you're saying if not if. Okay.
Now, you might say, well, Mr. Sylvester, how is gonna check for a value if I'm saying if it checked for 90, but then how am I gonna check here? Let me ask you this. If a score is a 65, when I check greater than or equal to 90, if it is, what? It's all this, and I'm finished. But then if it's 80 something, once I check for 90, it's gonna go from here, and so that's excluded.
Right.
So then it's gonna say from 80, greater than or equal to 80, but what? We already eliminated this, so it only checking what? That portion. Everybody understand? So we don't have to say greater than or equal to 90 and less than or equal to 100.
Right.
You got me? Because it's going to that and above. Then the same thing, if it's in between this, greater than or equal to 70, it's going to check this. Greater than or equal to 60, it's going to check this. Now, but if I done checked all of this part would automatically be the what? The if.
Right.
So I'll just do else, no else if. I'll just do a what? Else, do this.
Okay.
All right? So, let's look at it. Let's write that code. So, I do the else if, I did the B. What I'm gonna do, class, I'm gonna do a copy. When you copy, you gotta make sure when you're copying that you make the proper changes. Because you can copy something and have duplicate information and you're wondering what's going on in my program, right? So, else if this, but then I gotta do what? Else if, right? So now, this can be, what I can do is tab this over to make it to where it's indented, right? So I can see where my levels are, correct? All right, so see here, this if, I have this one nested, this one nested, and then this one gonna be nested, all right? All right, all right. All right, so this would be 70. What did I do? This would be 60, and that's based on the 10-point grading scale, right? And then what I'd have to do here, else, else, and then what? Grade equals F. Right? So now down here I can output what? Grade. Okay? I can output a grade and score. All right, I'll do score. And then I'll just output grade. All right. So I'll delete the BRCC. All right, so I have this written, so let's run it. Hopefully I got out all my errors. Kind of. Let's see what I didn't terminate. Oh, I started a stream here. Yes. All right. What's happening here? See how admin program, that's the same thing. All right. Unrestricted.
We want to output score, right?
I'm doing score and grade. Oh, look, I didn't close my what? My curly brace. All right. So we run it. See? Score is what? 82. It's a B, right? But let's change that. Let's change that, and I could have did a CN, but I didn't. Change score to like 55. What it should output? See? So see what happened. The first, and let me put 92. And see, well, the thing is, okay, run it. It's an A. All right. So the thing is, what happens? When it tests and it finds that the grade is greater than 90, it doesn't do any of the rest of that, right? It finds it and then it kicks out and print out the score and the grade, right? But not until it find what? Till it go through, if it's less than all of this, it has to go through all the tests and get to the last one and then kick out. Everybody see that with the 55, all right? Now, Mr. Gadd, you had asked, well, how do you program for everything, right?
Yeah.
All right, so looking at this program, once I got it to work, I tested it for what?
The grade.
F, I tested it for a B, I tested it for an A. Now, I need to test it for a C and a D also, because I could have something wrong in that if logic.
Right.
So you understand? The testing part becomes crucial. And I would tell you when you do your assignments and later on when you're working on code, test all of your logic, test the ifs. You know what I'm saying? Test for all conditions. Because you don't want to develop something and then you put it out on the market or somebody independently get you the right code and then, oh, I got it, it's working. And then they get it and then it's like, oh,
So it
this
seems like networking is pretty important because, like, as far as like talking with people,
definitely, oh
it can
yes.
help you with your
Right.
characters.
And you know, my experience with people who work in the computer science area, we introverts, you know? We like to get it done ourselves. We like to try to work on it ourselves. Well, I'm gonna work on it by myself, trying to get it done. But we can't be that way always because we have to network. We have to work with people. You sit next to me, right?
Right.
I'm working on something. You working on something. You have a little more expertise in that field than I do. I have a little expertise in another field. I need something from you. You need something from me. But we're not gonna talk to each other. I'm gonna go get a book or go wherever and research it. When all I had to do was,
Just ask.
excuse me, how does that? Oh, you do this like this, and it's done.
Yep.
You understand? So we gonna have to be more open, you know,
Right.
with one another.
And you
So
can talk to them like, hey, how'd you do
correct. And even with your assignments, sometimes students turn in an assignment, like Mr. Tucker, he's not here, assignment, missing a semicolon. And it's like, you had to have ran it to get an error,
Yeah.
but all you had to do was talk to somebody, look, hey, I ran this program, I got this, why not?
Right.
Oh, look right here. Because they know a little bit more than you. That don't mean you weak, that doesn't mean you cheat.
That's how you get better though.
There you go, that's right. If somebody can point out your flaws, take that.
It's just like when I was playing basketball, you always want to play against the best
The
player.
best player so you can become better. Right, that's right. You understand? So we got to get out of that, oh, I'm gonna do it, I wanna do it myself. I wanna go through it and get, you create a headache.
We play so many video games, that's why.
Right, yeah. But like I said, we got to be able to do that, man. All right, so that's a nested if. But hopefully you understand the if. Let's go back to the notes. Now the notes gonna be plain, the notes won't have code, the notes gonna be just simple pseudocode. So, Look at our operators class. We went over those. Less than, greater than or equal to, less than or equal to, equal to, double equal, and not equal. Now, and I always say this in class, and I blame it on our culture in the South. And like I say, some people they got it because their English is perfect. But the double negative is a positive, right? We know that. Computer know that too. Many times we as individuals in the South, the way we talk with double negative, but we understand what we saying, you know? But we gonna have to kind of conform to the proper way.
I ain't never done that.
Right. You see, when you use that, right, when you said, and you say, no, and then like a negative with a negative make a positive. But we think, okay,
We
yeah.
understand that, yeah.
Right, we understand what that is. But we're gonna have to kind of understand when we code, you can't do that. Because you're gonna get frustrated. And ask me about it, I've done it. I'm like, oh, okay, yeah, I forgot. Yeah. Right?
Yep.
Because that like that not. Look at that not equal. If I go here in this code and I say, well, I took it all out. Everybody see this. How you save it to the, I want to save it like Mr. What's your name? Mr.
Robert?
Last name?
Yeah.
Mr. Robert. How you save this so you can come back to it? Because I don't want to
Oh, at the top it says save.
click save.
Yeah, you gotta be logged in.
I'm logged in. I think by default.
Are you trying to do it on your email?
No, you log in to online GDB. You can log in with your Google.
Or you can copy and paste it.
Right, but I did want to, because you leave it there, so like, because y'all might ask another question about it,
If you
then I don't want to retype it.
Yeah.
if you got your Google account,
Yeah, I got it,
yeah,
yeah.
just go on there.
Okay.
I mean, I just copied and then pasted and then sent myself an
Right,
email.
but he showed me where he logged in and he saved it. And it's like he could go back in and it's there, and he pull it down.
Yeah, so just name it.
Project grade. Alright.
And then just go to my project.
Yeah, I don't want to pull it back up.
Yeah.
I'm gonna take this out. Alright, so now, so if y'all got a question, I can just go back to it. Okay. Alright, so if I said something like this, int y equals 3 or 100. 100. All right, so what's gonna happen here, class? Looking at this code,
Let's say no.
all right? It says y is equal to 100. If y not equal to 100. So the thing is saying, it's like 100 is not equal to 100. That's true or false? 100 not equal to 100 in this instance, true or false?
That's
False.
That's true. 100 is not equal to 100. Oh no.
Yeah, but you understand, and that's just a little mind twister.
Yeah.
But I'm just saying that's how we got to look at
You
it.
missed the L, by the way.
I mean, on the line, yeah, right. But I'm just saying. But you see how just simple like that. It's like because it's our culture that got us that way, you know. So we got to remember how to evaluate this, because we be writing code like, man, I know it should be outputting something. Why it's not doing it? I know the values, whatever. In our mind, we see it,
Right.
but we can't put it on the paper. So we got to be able to understand it, right? So when we run it, right, it should say 100 is not equal to 100. That's false. 100 is equal to 100. All right? All right? So we run it, it should say no. See? No. Alright? So you got to kind of keep that in mind when we're doing them knots and whatever. Alright. Let's see what else. So looking at this, it's asking this question. X greater than Y. X less than Y. X greater than or equal to Y. X less than or equal to Y. X equal Y. It's comparing, right? X not equal Y. Alright? So you got greater than or equal to, which we understand they're going to include that value. And give you an example. I give a program with if logic, and I'll say, okay, write a program that will accept a value between the numbers 5 and 10. We're dealing with integer. What are the valid values?
Between 5 and 10?
Between 5 and 10.
6, 7, 8, 9.
Right. Not 5 to 10.
Right.
Between.
So it's not included.
Right. But what I'm saying, see how our word problem skills has to come into play. Because you start writing code and you're dealing with whether or not a person needs to be accepted or denied or given a bonus or not, and you let that one group of people in or whatever that really wasn't supposed to get it, then the company is whatever, right? So you got to pay attention. And that's why, like you say, talking and networking, when somebody can call up and say, oh, they say right here is this, is that what you meant, whatever?
Even someone who doesn't even know how to code sometimes can see something like, why is there a semicolon right there?
That's right. And that's why I was telling you, like a lot of times if somebody that done code, could be your nephew, your brother, sister, whatever, and they're asking you, well, why is this, that? Well, yeah, well, this always, you got to have a semicolon here, this, that. And then when you're going through it, because I got an error with it, well, why you don't have one right here? And you're like, wow, they don't know how to code, but they didn't look through it because they coming in with.
I'll show one of my friends the sum one calculation. He was like, he actually added up all the numbers. He's like, well, that's not right. And I was like, I forgot what I did.
But you see what I'm saying? Yes. They just like, new eyes. They look at
every
it.
time now, every time I do one of our assignments, I always check the logic to make sure the logic's right.
But didn't I tell you that? Because just because you have an output doesn't mean it's correct. Like you might say, okay, say given on a larger scale, you might be doing a report to collect data on, you writing the code to collect data on, say, people from the state that may, they say like if you're working for the Louisiana IRS, and people that owe above a certain amount of money or whatever. And you go ahead and write the code, whatever, and you get a report, but you done excluded half of the people because something in the code you messed up. Right. So just because you got that output, man, sometimes it's good to go manually and spot check.
Yeah.
Okay, let me see if this, let me see if that. Just to make sure that all your code is working properly.
Because just because it runs doesn't mean it's right.
That's right. Get that logical error, that's the hardest one.
Sometimes it's not obvious, you know what I mean? You say the program is $0, you're like, well, that's not right.
Right. Some of it is obvious. And sometimes what we do is, we so gratified that we got output.
Right.
Man, I'm finished, I'm done, or whatever. And it's like, no, you got logical problem. Yeah. But yeah, and like I say, because
once you start getting it running, you're like, oh, thank God, okay.
Right, that's right, yeah. Yeah, you're gratified, you're happy. And I'm gonna tell you, people gonna call you crazy, because a lot of times, you might be stressed out trying to work on something, get it, and when you get it, they hear you hollering in the room or you know what I mean, whatever, like, what's wrong with him? But you're so happy that one little semicolon, that one little command allowed you to get some output. And like, God, I got something. Right. It happened. Oh, you sitting at the dinner table.
Yeah, you got life now.
Huh?
You got life now.
Right, that's right. You're sitting at the dinner table. Oh, I need to go check this. And cause it's on your mind. And if you don't try it, you'll forget it. You know, and that's programming. That's all the part.
That's real life. I mean, that's real life though.
Correct.
Yeah.
Right. That's right. Yeah. All right. The not equal, we just went over. Now, putting it all together, this. If sales is greater than 50,000, we know how we'd have to have what? If statement, and sales would be a variable, but there'll be a parentheses here and a parentheses here. Now, we know we won't use the then, right? That's just pseudocode. Everybody understand that, right?
Yeah.
Then is just part of the pseudocode. Set, part of the pseudocode.
So what does then actually stand for? Is that the curly
The curly bracket. Right. Look at this. If I have, yeah, I have an if here. So, if y is not equal to 100, then do this. I mean, do the true part. Else, do this. Now, if I did something like this, that's something like set y equal to y plus 1. That's what the set is. Like,
Right.
yeah, kind of
So it'd be like 100.
assignment, yeah, 100, yeah. Right. So that's what the set in this here. Like set bonus equal to 500.
So could you put y plus plus instead of, it doesn't have to be,
Right, but we didn't look at, I don't think we looked at those yet. Plus, minus,
yeah.
and pre and post.
Yeah.
Right.
Plus just add one, right?
Right, minus.
That was like one of the very first things we did on the solo learn.
Oh, y'all did it?
Yeah.
Okay,
Yeah, so-
well, we might need to continue, but it's not in the book yet. It's not in
Yeah, it's
there.
not in the book.
But what happened, you have plus, minus, but you have a pre and a post.
Right.
Now, what's the difference between pre and post?
Post, it adds it right away.
Nope,
The
the pre,
pre, okay. Post doesn't add it until like after.
the next execute will say,
Right.
yeah, right. So, Mr. Gaddis, Mr. James, you heard what he just said about the pre and the post? Okay, so this is what I'm gonna do. Wait a minute. Okay, I'm gonna go to the program. I'll take this if logic out. And I'll say, okay, y is equal to 100, right?
Right.
Okay, I'll say, how would I do that? X is equal to y plus, okay? Right? So, and now I'm gonna see out, if I could tell you. All right.
Oh, yeah.
So what is I need to do a tab. So what is what's gonna output for X?
101. Right.
Ms. James, what's gonna output for X? I mean, yeah, y is equal to 1, I didn't give X a value. I mean, declare it.
By the way, if you're trying to save something, it'll overwrite your last save.
X is just X.
So no, I'm talking about on the left. You see, remember how you're trying to save it?
Oh, because the name is still the same.
Yeah.
So it's overwritten anywhere.
Oh, did you overwrite it?
I didn't save it.
Oh, well, then you're good.
Okay.
Until
All right. Until I save
got it
it.
sent to my email, so.
Okay. So what Miss what's your name here, Miss Hunter? What will I put for X? 100. Miss Hunter said 100. Mr. Gaddis said
101.
101.
Hold on.
101. Miss James. 100. Miss 100. Oh, so the ladies say 100. Why y'all say 100? Because she say 100, I say 100. Ladies got to stick together. So why you say 100? Give me your educated opinion.
The plus came after.
You hear what she said?
What you say?
The plus came after post.
Right.
So y is not incremented until
So what?
the execution of the next line.
Oh.
Yeah. So if I run this, X is 100.
Right.
See? But watch this though. What I'm gonna do? If I output Y, when I output X, X will be 101. Watch. So here I'm gonna output X. And I'll say, I'll do Y. I missed something?
Yeah, you gotta put that.
Oh, the stream. All right.
Oh, I get it. I get it.
But you understand?
Yeah, I see it now.
All right. So let me ask you this. I'll say 3. Oh, I do. X equal. X is equal to 3, right?
Right.
What's that?
This is 104.
You're right.
All right?
Yeah, you're right. Because what? This is post.
Yeah.
This is pre. So on that, at that time, on that
Oh,
line,
yeah,
it's
you're
gonna
right.
add 1 to X, which what? Changes it to what? 4 plus 100 is what? 104. Then what happens? Y becomes 101 on the next line. Right? So you kind of understand that pre and that post, you can get caught up in it. See?
Why not just make it free?
No, but you might want to use it after that, not at the same
How
time.
often do you use that operator though?
You use it when you use it with the for loop.
For the, okay.
Because we start at a particular point, and as we iterate, we increment. Not until we come back to the beginning, or when we leave it increment. Right. So we do
It's
use
like
it.
a, you can do like a ratio with that, right? For every,
No, it just add.
I don't understand. Okay.
It just add.
If
Look.
it was plus Y,
Huh? Okay, if you add plus Y
it's
plus X.
105.
Huh?
It'd be 105, right?
What that would be?
98?
103.
101 plus 2.
It was minus.
You minusing 1 from 3.
Oh yeah.
So 101 plus 2.
103.
See, but you understand? Yeah.
It's confusing because
It is confusing, but that's how it
Yeah.
works. The pre and the post. Alright? Pre and post. See? Right. Pre and post. Pre, I'm gonna do it while I'm on that line. Post, I'm gonna keep the same value and do it after. Now, this is one thing we wrestled with once, and I did plus. So what happens here? I don't really know the answer. I think but they're gonna change it. It's gonna change it to a negative 2. I mean to a 2. Then they're gonna change it back to a 3. So it's gonna be 3 plus 3 plus the 1 will give us 6.
how?
Cause you
How,
gonna
how would that last one not be 4?
Because it changes it on the minus. It changes the value to
yeah, it changes to 2. Then it changes it back to 3.
Oh.
And then 3 and 3 is 6. Yeah. So you understand what I'm saying?
Right.
Right. And then, cause you're changing that value in that, that value in that memory location. But I gotta make sure I evaluate them all, you see? So this went from 3 to 2, then it went back up to 3. So 3 plus 3 is 6,
6, right?
plus
Okay.
the 1 here. Well, wait. Wait.
No, that's good. You said 3. You're supposed to say 2 on the second one.
This one, it's 2.
Yeah.
Thought this one, oh, yeah, okay. But now if I do
You
this,
get tripped up, huh?
if I do this, yeah, it was 1, 2, and 3. All right. Yeah, because this brought it to 2, that brought it back up to 3. So what's gonna happen here?
100 plus 3.
It's 108.
That'll be what,
Plus
3?
4, so 107?
See, this will be 3, and this will be another 3. Now, this will be 4, right?
It'd be 108.
4 and 4 is 8, should be 9, huh?
No.
So it'd be 107, right?
Always go from left to right. Yeah, go from left to right. You do the 1 here, you do the 1 here, You do the 3 here and the 4 here.
Oh. So I wasn't even evaluating the Y. I was
Left to right.
The X and the.
Yeah, left to right, yeah. Left to right. Right. Alright. But that's pre, and then the post, same thing, whatever. But the post won't happen until when? Till the next line. Right. Till the next line. Alright, but that's pre and post. Now, it ain't time, Mr.
2:47.
It ain't time, no, it's not time.
Yeah.
It's time.
Alright, alright. So, look at the scores. Remember, we did this one here. Well, this doing the average. Basically the same thing. We just put in the actual test score, right?
Yeah.
Which you could calculate an average and then find out what the grade is too. So that's what that pseudocode is. Alright? So, next time we come back, we did this too. The if, then else. We did that. So we covered that. Well, we're gonna kind of cover it again to kind of give you understanding. Alright? So we'll meet up on next class period and we'll kind of work on those. I might post some stuff out for you to do. We'll
Maybe we
see.
can do some practice, like a reference program, like passing my reference programs.
Oh, you want that?
Yeah, because I'm pretty comfortable with passing my values,
All right. But passing by reference, you're just using the ampersand, but you got
but I like
to.
to practice it, you know.
Right. But you got to remember, say if I pass, say a test score by reference.
You're passing by the address.
Right. But if I pass it and I make any changes to it, say I do a plus to it.
Right.
Like if I add a bonus, like if I add 10-point bonus to it in that function.
Right.
When I return back to that calling
It's
function,
gonna be the
change. It's gonna be changed.
Right. It's not gonna be like the value one.
Correct. You gonna
The
change.
value one's gonna be whatever it was.
No,
doing.
It's gonna be changed. When you pass by reference, it changes.
No, I'm talking about passing my value.
Oh yeah, you're right.
The value's gonna stay the same whatever it was.
Correct.
it was called the value.
Right. It protects you from changing that data in that.
So it's better to do by value, by reference though, huh? Because you manipulate.
The program runs a little faster when you're dealing on low level,
Yeah.
right? But at the same time, sometimes you may not want to change a value.
Right.
So you may want to pass it by value than reference. So like I said, it just depends on
The situation.
what you write in that program. Because sometimes you want to change it because you don't want to have to return back to assign it to whatever. You know. So it just depends on how the code is to be written. Yes, sir.
Thursday, if I miss class, I'm gonna miss anything other than
Right, now we're gonna go over the notes, right. And then what you do, look on Canvas. Oh, y'all supposed to get y'all that wipe to wipe it off again. But I guess we can do it at the beginning of class. Yeah. Right? We can do it at the beginning. I might have quiz or something, all assignment listed, so you could check, just check Canvas.
oh,
All right.